In this lesson, we will talk about how to summarize and display quantitative variables. There are three main ways that we will do this: the dot plot, stem plot, and a histogram. So a dot plot is a very easy visual way for us to basically place a dot above a value each time it occurs. And what results looks kind of like a bar graph because we can compare the height of these. Now, if you let technology do this for you, it's fantastic because we don't have to work very hard. However, if I'm doing this by hand, it's very easy for me to not space the dots out as far as they should be or as close as they should be, and it makes it very difficult to see any of the patterns that exist in our data. A stem and leaf plot is okay. It's definitely not my favorite way to go. It's similar to a histogram again because it's kind of like I'm looking at the bars and how far out they go. The same disadvantage as the dot plot that we just talked about is if you write your numbers different widths, then a bar can appear larger than it actually is. When you do a stem and leaf plot, whatever the last digit is, the trailing digit, is always going to be a leaf. So to read this, this would be a 21, a 35, a 40, a 43, etc. And I could keep going, but I'm not going to. And you can see that that's how we find out what those values are, because the stem in this case is the ones digit. So we have a key that tells us how we do that. There are two other stem plots that you could use. The first is a split stem plot, and that would be useful if you have a large data set. You would use the the leaves of 0 to 4 for the first stem and from 5 to 9 of the second stem, just to sort of break it up so you don't have a giant list of things. The back-to-back stem plot is useful if you're going to compare two different distributions. So this would be the pulse rate before exercise and the pulse rate after. Obviously the pulse rate before is lower and the pulse rate after is higher, which we would expect with exercise. And a histogram is great, and notice that it's very similar to a bar graph, but there are a couple of things that are different that I want to point out to you. One is that there are no spaces in between the bars. It's important to note that there are no spaces, and notice here that the x-axis is essentially a number line. So it's going to go from least to greatest, and there's not going to be spaces in between, which is why there are no spaces in between the bars. So it's a continuous number line. In order to create a histogram, we would follow the steps I have listed on the screen. So first we would divide the range of data into bins of equal width. So a big mistake that people make when creating a histogram is they'll say, all right, my first bin is going to be from 0 to 9, and then I'm going to go from 10 to 25. Well, this has 10 possible values in it, whereas this has obviously far more than 10 possible values. So this is not going to work because I want the same number of chances within each bin. We're shooting for 5 to 20 bins. Then I'm going to count the number of observations. So again, we are probably going to use technology to do that, but you're going to count the number of observations that fall into each bin. And then we're going to draw the histogram. The vertical axis typically has the count or frequency. That's this one. So just as we did before with the bar graphs, the horizontal will have the scale of each bin. So if I was going 0 to 10, I would put a 10 here, and my first bar would go from 0 to 10. Again, no spaces in between. So again, touching bars, use technology. It makes it so much easier, and of course I'll show you how to do that.